Hello, and welcome to this video on the basics of electrotechnology. Here we'll be explaining what voltage, current and resistance is, where to place a multimeter in a circuit to take a reading, how to use and read digital and analog multimeters, and how to take a reading. Now it's time to look at what the definition of these words mean. Voltage is the difference in potential energy per charge expressed in volts. Current is the flow of direction of electron measured in amps. Resistance is a material's opposition to the flow of electric current measured in ohms. Measuring voltage. Voltage is probably one of the easiest measurements to take and one of the easiest to understand. First, you take your voltmeter, or in our case we'll be using multimeters, and you place each of the probes across the component you wish to measure. In this example here, we can see we are measuring the voltage of a resistor in the middle here with the voltmeter, and the volts we are receiving is 9.0 volts. Now it's time to look at measuring current. Current is trickier than voltage to record, as you must open the circuit up and place your meter in line with the component you are trying to measure. So as we can see in example B, the circuit has been opened up, and in part C we can see that the amp meter, or in our case it will be a multimeter, is placed in line of this resistor to take its current reading. The flow of power from the power source must go into the amp meter and then out of the amp meter through the resistor and back. So this is why it's much harder to take a reading, as sometimes you'll encounter circuits where you can't easily break them to take a current reading. But for our example we'll be looking at later, this will be no problem. Measuring resistance. Measuring resistance is once again different from voltage and current in the way you take the reading. In our example, we can see that we want to take a reading of this resistor here. First up, you must remove the resistor, and then you connect that resistor to your ohm meter, or we'll be using a multimeter, like so, to get the reading. In this example, it's 2.2 kilo ohms. The polarity, or the way you connect the probes on either side, is not important for this reading. Multimeters come in varying different shapes and sizes, but today we'll be looking at the digital and analog variants. Both of these types have a display at the top, the selection knob or dial in the middle, the ports where you attach the hookups or cables. Before we learn how to read a multimeter, we must first make sure that the cables are connected to the right ports. The black cable, the negative, is always connected to the COM or common port, and the red cable, which is the positive, will be connected to the terminal of which you want to take a reading of. In this picture, we can see that this cable is in the correct position to take a reading for volts or resistance. If you were to take a reading for current, you'll be connecting it to one of these two ports. The first meter we'll be looking at how to read is a digital multimeter. The digital multimeter is very easy and straightforward to use, and why it's favored by many people. In this example, we can tell we are measuring voltage as the dial is set to 20V on the DC voltage. On the screen here is where it shows your current reading, and we can tell that it is 4.98 volts. Example 2, we'll be looking at resistance. Firstly, the dial is set to an ohm rating, 2 kilo ohms, so we know that this is reading resistance. In the picture we can see that we are measuring a resistor, and we are getting a resistance of 0.329 kilo ohms. Moving on, it's time to look at analog multimeters. Analog multimeters, like the one below, may at first glance seem to be a bit trickier to read, but once you know how to do it, it is very simple. In this first example, we'll be looking at voltage. The first thing we can tell why it's voltage is the dial is set to DCV or DC voltage. These numbers along this dial here correspond to the bars we can see across the top here, 0 to 30 and 0 to 10. As this dial is set to 30, we'll be using the top bar as it has a 30 on it. If this was set to 3, we'd still be using the top bar as these are all the multiples of 3 and it's much easier to read. If this was set to 10, then we'd be using the second scale along the bottom as these are all multiples of 10. So to read this example here, we can see that the dial is set to 30 and the needle on our reading is set to 15. As this is 0 to 30 and our dial is 30, then our final answer is 15 volts. Now let's have a look at an example of a resistance reading. First we can see that the dial is set to the resistance setting as there is a symbol of ohms here and it is in the green section. So we'll be using the green scale of our display. As you can see, it goes from 0 all the way up to 1K and 3K at the very end. So this will be reading from right to left. First, you must look at the dial to see which range it is set to, and then you can take your reading. So we have a reading of 10 from the position of this needle, and these can be looked at as multipliers. So it is times 1K, so we must times whatever reading we get here by 1000 or 1K. So a reading of 10 will give us a reading of 10,000 or 10K. So the reading of this example is 10K ohms. If this dial was set to, for example, times 1, then our reading would be 10 ohms. If this was set to times 100, then this will be 1K ohms or 1000 ohms. Our last example will be measuring current. Once again, you can see that where the dial is positioned, we are reading current as our results are recorded in milliamps. We'll be using the top two scales, just like voltage, to take these readings. First, you must look to see where the dial is placed, and it is a number 1, so we'd be using the second scale on the bottom. If it was a number 3 or 30, then we'd be using the top one as it's a multiple of 3. So for this example, we have a multiplier of 1, and we look on the scale 1 to 10. It is in the middle, right in the middle on the 5. So for this, the answer will be 1 milliamp. If this was set to 3, and this needle would be in the same position, then the answer for this would be 1.5 milliamps. This is so because you have to divide 30 by 10 as it's set to the 3 setting and not the 30, so 15 becomes 1.5. Finally, we will look at how to take a reading. Taking a reading is very simple. All you must do is take the black and red probes of your multimeter and place them on the circuit where you would like to take the reading. In this example, we are taking a reading of a 9-volt battery. The black is in the negative terminal and the red is in the positive terminal, and you are taking a voltage reading. If you need help remembering how to connect your multimeter for each reading, just look back at the examples given previously. In this segment, we'll be looking at Multisim, which is a powerful simulation software for creating circuits and other things, and we will construct the LED circuit found on the AI2 robot, and we can take simulated measurement readings which we can later compare to the readings we take off the actual robot. First, we need some components to create our circuit. We start by adding a DC power source. We'll need a ground. We'll also need a resistor, 330 ohms. And we also need the LED for our robot, or for our circuit here. The LED here is a 5 milliamp, but we need a 2 milliamp, so we'll change that to 2 milliamp LED. Lastly, you just connect all our components in our simulated circuit. We must also change the power supply from 12 volts down to 3. We can run the simulation, but we won't get any readings without any instruments. So let's place down our first multimeter to check the voltage. We add a multimeter to the right, and we connect it as we did in the previous presentation. So here we'll measure the voltage across the LED. Make sure it's set to volts and to DC current, and we'll start the simulation again. As we can see, we're getting 1.74 volts across the LED. Now we'd like to take the reading of the current of this simple circuit, so we'll have to modify it as follows. We have to insert the multimeter in series after the resistor but before the LED. So we add the points like so. Now the multimeter is inside the circuit, and we can correctly take a reading of the current. The reading we're getting is 3.819 milliamps. Finally, in Multisim, I've set up 3 separate circuits showing the correct way to measure each of the desired values with multimeters. The first one we have voltage, the second one we have resistance of the resistor, and finally we have the current of the circuit. As you can see, each meter is correctly placed to get the correct reading. This is very important, as placing your meter incorrectly will not give you the correct results. Now it's time to move on and look at some readings of the AI2 robot, just as we have done in our simulation software. Now we're going to take the voltage reading from our AI2 robot. Now the voltage we'll be looking at would be the front left LED light module that lights up when the robot bumps into something. Now the first thing you want to do is get either a big rubber band like this, or you want to get a friend to help you hold it, but I definitely recommend a rubber band. And you also want something to rest it on if you're doing this by yourself, so it doesn't roll off everywhere. Alright then. Now the first thing you want to do is to turn on your multimeter, and you want DC voltage. So as I'm not sure what sort of voltage I'll be getting out of my little guy here, I'll set it to 200 to start with, just to see what reading we get. Now on the AI2 itself, the points that we want to measure is on this front left LED module. What you want to do is get the black probe, and you want to be touching this very bottom one here, and with the red probe you're going to be wanting to touch it on and place it on this middle one here. So I'm going to demonstrate that for you now. and we want to keep our eye on the multimeter to see what sort of range we're getting as well, to double check this dial here. So we'll turn him on, go to control, go up to bump robot and tell him to go. Alright, so we'll take our probes and we'll take our first reading with the red in the middle and the black at the bottom. So we're getting 1.8, but that doesn't tell us quite enough, I don't think. So what we can do is we change it from 200 down to the 20, and we'll take another reading and see if that improves our answer or makes it more accurate. There we go, we're getting 1.91. So that's a little bit better. And just to demonstrate, just for science, we'll swap it down to the 2, and we'll take one last quick reading. There we go, that looks a bit nicer, 1.915, which of course we can just round up to 1.92. So there you have it, that's how you take a voltage reading of the LED module inside the AI2 robot. Now it is time to take the current reading of our AI2 robot. Now to take a current reading, you have to break the complete circuit and insert the multimeter into the circuit so the current flows from the power source through the multimeter and onto the item that you want to measure the current of, which is in this case is the LED eye module at the front of the robot here. So to break the circuit, so to speak, you want to turn the robot over, and we're going to remove the middle screw here of the LED module. Now that the screw and front claw are removed, we can take our current reading. What you want to do is take the black probe and put it on the left hand side here of the LED module in the middle, and our red probe will be on the opposite side of that, on the right hand side where the motherboard is. So we've set our multimeter to 1 because we're not sure what the reading will be, so we'll just do that to test to start with. So we'll set it to the bump module once more, and that will let us take a reading, and if the circuit is closed, once we take our reading, the LED light would turn on, and we know that we've done it correctly. There we go, the LED light's on, but as you can see, the multimeter went off the chart, so we're going to have to turn our scale up to the next notch, which is the 3 setting, and we'll take another reading. Probes on either side. That looks a bit better. We are getting a reading of 26, but because we're on the 3 setting and not the 30 setting, we have to divide our answer by 10. So we are getting about 2.6 milliamps across the LED light module of our AI2 robot. And that concludes on how to use multimeter to take voltage and current readings from this little guy, the AI2. Thank you for watching.